Today we're going to take a little more time looking at graphs of absolute value functions. So if we look over here at our parent function, f of x equals absolute value of x, our basic absolute value function, we have a graph here. And down below it asks us, what's the slope on the interval from negative infinity to 0? So as we go from negative infinity all the way from the left, keep coming until we get to 0, the slope is always the same. What is that slope? Well, that slope right there is negative 1. Right? We're going down 1 over 1, down 1 over 1 that whole time. So we have a slope of negative 1. How about the slope on the interval from 0 to infinity? So starting at 0, going towards infinity, right, towards the right, what's our slope there? Well, slope there, we go up 1 over 1, up 1 over 1. So our slope to the right is positive 1. And we have two other graphs we're going to look at here. And f of x equals 2 times absolute value of x. Well, what happens here, this is a vertically stretched function. Right, a vertically stretched function is more narrow than the parent function. Right? It's taking this and stretching it vertically, and that makes it kind of taller and skinnier. So let's look at what we get here. The slope on the interval from negative infinity to 0. So now, on the left side of our vertex, as we're coming from the left, what's our slope? This time we're going down 2 over 1, down 2 over 1. So our slope here is negative 2. How about the slope on the interval from 0 to infinity? So to the right of the vertex. Here we go up 2 over 1, up 2 over 1. And then our last one, this is a vertically shrunk function. It's more wide than the parent function. So we're taking it, kind of stretching it horizontally. Well, we're actually shrinking it vertically, but it kind of looks like it's stretching horizontally as well. So we're kind of taking it, pushing it down, which makes it kind of short and fat. So this one, if we look at the slope from negative infinity to 0, so from the left side, our slope is what? Well, we're going down 1 over 2, down 1 over 2, so we have a slope of negative 1/2. And then to the right, slope of the interval from 0 to infinity, so the right of the vertex, we're going up 1 over 2, up 1 over 2, so we have a slope of 1/2. Now, what do you notice about these functions here? If you look at the equations and look at their slopes, what do you notice? Well, you should notice that this number right here, that we have out in front of the absolute value that we call a in our formula, that value of a tells us the slope on the right side of the absolute value, right side of the vertex. Right, so here we have a slope of 2, we have a 2 in our equation. For this one, we have a slope of 1/2, we have a 1/2 in our equation. That gives us the slope of the right side. The left side is just going to be the opposite of that. And that's what's written right down here. Right? If our formula looks like this, f of x equals a times the absolute value of x minus h plus k, this value right here, a, is going to be the slope to the right of the vertex. And then the opposite of a, right, because a could be a negative number, we can see that up there, but it can be negative. But the opposite of a is going to be the slope to the left of the vertex. Also, one thing to remember from before, hk, remember that is our vertex. Right, this number that's being subtracted from x is our x-coordinate, and then the number out here is our y-coordinate.